if I have anything like x plus 5, x plus 2, and x plus 3, it is just an example. Okay, we'll directly do it with the help of example. So if I want to write it in the form of some a over x plus 2 and some b over x plus 3, so this is called as partial fraction. Now, what is the utility of partial fraction? So partial fraction will be asked directly as a question, like this can be asked directly as a 3-marker question, and it can also be asked in integration, in differentiation. So this can also act as a tool in your whole calculus. If a question will become very difficult, then it can have partial fraction in that. So there are two purposes for this chapter. One is directly questions like this, and the other one is calculus. Calculus will not do over here, but let's say once we get till here, then these terms are very easy to differentiate or integrate. That we'll see over there only. So this is the overall utility. I'll just show you the method and then I'll give you another question to try on your own. So this is the first step to begin with. And then the second step is that you will take LCM. So LCM of x plus 2, x plus 3 will be these two only because there is nothing common. And then x plus 3 will go here. So a times x plus 3 and x plus 2 will be multiplied here. And on the other side, I have same terms. So x plus 5 over x plus 2 and x plus 3. Now you can just notice that we have same denominator on both the sides. So we can cancel it. Writing 0 in the denominators after cancelling is a wrong thing. Whenever we cancel anything, let's say if I have 2 is equal to 2. So when we cancel it, it is 1 is equal to 1. 1 is always there. So that's why both the denominators are 1. And now we are free to go ahead with our further steps. So it will be x plus 5. On the other side, I have ax plus 3a plus bx plus 2b. This step is optional. You can cut short this step and you can directly write it down as a plus bx plus 3a plus 2b. And once we are done with this step, we are good to go ahead and compare both the coefficients on left and right, and then we will get two equations. What do I mean to say by that? Look at the coefficient of x on right and coefficient of x on left. What is the coefficient on left? Can anyone tell me?
1.
1. When nothing is given, then we consider it as 1. So I will get my first equation, a plus b is equal to 1. And my another equation will be 3a plus 2b. Now just look at this 3a plus 2b. It's a constant term because it do not have any x values in that. So that constant will be compared with constant. I'll just let you know that why we are comparing it. So by comparing the coefficients, we'll get two equations which can be simultaneously solved and we can get a and b. Now the question is that why we are comparing these two coefficients like this? The reason for that is we have equal to sign and we have something equal to something. So the simplest logic is that if ax plus by is equal to cx plus dy, then these are possible only when a is equal to c and b is equal to d. Just imagine if the value of a is 2, so I have 2x, then b is 3, so I have 3y. Now what I'm saying that a is equal to c. So these two are equal only when the value of c will be 2 and d will be 3. So this comparison helps us to get the constants, the unknown value, or to create equations like this. After getting till here, it is very easy to get a and b. So I will be just multiplying the first equation by 2. First equation multiplied by 2 will give me 2a plus 2b is equal to 2. And then second equation I'll write as it is. And I can do 2 minus 1. Okay. Let's say this is equation 1, this is equation 2, so I'll be doing 2 minus 1. 3a minus 2a will be a, 2b cancel, 5 minus 2 is 3. I got a as 3. I can put it in the first equation over here, the raw one. A is 3, so b will be equal to minus 2, and we are done. Now till here, we are just done with a and b values, but we have to still move forward and write the values of a and b over here, because my final answer will be a is 3. So I'll write 3 over x plus 2 and b is minus 2. So I'll write minus 2 over x plus 3. So this is the final answer and this we call it as partial fraction.